thank you so much for coming to the, I believe, last speaker session of the conference, which I don't know about you, but I've really enjoyed. I am very pleased to introduce Ryan Miller from the University of Geneva, speaking on Lonergan's oddly strong theory of emergence.
Thanks. Thanks for staying to the bitter end. So yeah, you might not have heard of Lonergan, but I'll try and make a pitch for why he's at least a little bit intriguing. And he did teach for a little while here in Halifax. Anyway, all right, so plan to talk. I'm going to go through Jessica Wilson's characterization of emergence. I just think she's got a, kind of a central position in the debate right now, though I don't think it exclusively applies to her. I'm going to spend a little time on exposition there because I think her position moves around a little. Then I'm going to give you Lonergan's account, and I'm going to show you some implications about why that doesn't fit as neatly into Wilson's schema as she might hope. All right, so Wilson's account of emergence. All right, so first she gives what she calls a kind of heuristic bit. So she says it's the coupling of cotemporal material dependence with ontological and causal autonomy, which is most basically definitive in the notion of emergence. So basically, if you don't do this, then you're just, by definition, not emergent. So if I'm going to count Lonergan's view as emergent, I'm going to have to argue that he does do this, right? But then she makes this striking claim, which is not really definitional, which is there are two and only two schemas for metaphysical emergence. One of which is compatible with physicalism, the other of which is not so compatible. So it's supposed to be just weak emergence, strong emergence. It's going to give you characterizations of each, no third possibility. That's what I'm going to go after. All right, so what do these two kinds of emergence amount to? Why, what are these two that supposedly are the only two options? So we got weak and strong. They have epistemic characterizations which are just kind of heuristic and kind of coming from the history of the debate because she's really focused on metaphysical, but this is part of the history. So weak emergence is not, the idea is that the higher level is not deducible in practice from the lower level, but it's supposed to be deducible in principle. So the lower level is just like really complicated. We don't have a computer big enough to like run all the calculations, but if we did, then the higher level would be evident. Whereas strong emergence is supposed to be not deducible even in principle. So no matter, even if you have a Turing machine at your disposal all the time, all the computing power, you'll never be able to deduce merely from the lower level goings on what's going on at the higher level. So that comes from the history of the debate, the British emergentists, etc. But she wants to focus on what she thinks are some largely equivalent metaphysical characterizations. The first one she wants to give is in terms of powers. So in weak emergence, token feature S for special science, the higher level, on a given occasion has a non-empty proper subset of the token powers, the token feature P for physical or base layer, on which S temporally materially depends on that occasion. So somehow this is like a little bit of Tyler's compression account if you were at the patterns account, or some of the compression account that we looked at in the summer school if you've been around, where it sort of compresses what's going on into some simpler form that does less but is somehow noteworthy for its simplicity. That contrasts with strong emergence in which token feature S on a given occasion has at least one token power not identical with any token power of the token feature P, upon which S cotemporally materially depends on that occasion. So here, you're getting a whole brand new power at the higher level. So it doesn't correspond to anything at the lower level. It's a real novel power. That's why you've got strong emergence. And then she thinks that while these powers definitions are kind of her preferred definitions of weak and strong emergence, then we might ask, well, why does she think these are the only two? Why is having fewer powers or more powers the only way to be emergent? That comes from a hexagon that she's going to offer, which I'll look at in a second, but just to pitch. Weak emergence is supposed to deny non-overdetermination, so you can have overdetermination cases, those are fine. The strong emergence is supposed to deny physical causal closure, so you could have downward causation, that's fine. All right, so let's look at that hexagon. So the first premise of the hexagon is dependence. Special science features cotemporally and materially depend on lower level physical features. Base features is a way that at minimum, the occurrence of a given special science feature on a given occasion minimally nomologically supervenes on base features on that occasion. So yeah, the supervenience is supposed to keep us from being dualist, right? If you deny dependence, you're just a dualist. But be careful about what she means here, because minimal nomological supervenience, actually it's supposed to both if A supervenes on B according to Wilson, it both supervenes on and A both supervenes on and requires B in any nearby worlds with the same laws. So it's actually stronger than you would normally think of supervenience being because it's a little more symmetrical. So dependence is tight for Wilson. Second, reality. Both special science features and the base features are real. Obviously, if you deny that, you're a limitivist. Third, efficacy. Special science features are causally efficacious. If you deny that, you're not a phenomenalist. Then distinctness. Special science features are distinct from the base features. If you deny that, then you're just straight up reductive physicalist. And then physical causal closure. If every lower level physical effect has a sufficient trivially lower level physical cause. So if you deny this, then you're a strong emergentist. And then there's non-overdetermination, with the exception of cases of double rock throw variety. So that's right, when we both throw a rock through the window at the same time, the window shatters. You say, well, look, it would have shattered no matter which one happens. And you say, okay, that's true. There are cases of this kind of overdetermined causation, but we think those are kind of special. Like most of the world is not like people throwing rocks at the same time. Those are special, weird cases, and we have a good account of why they're special and weird. Normally, even if we both threw rocks, one of them would hit first or whatever. This requires like a lot of synchronization. Whereas in this case, the idea, if you deny non-overdetermination, you're okay with this being just kind of pervasive. Like all the time, things happen, and they'll just have like different causes. Presumably in this case at different levels. So it's just going to be pervasive overdetermination of causation rather than being a rare exception. And if you deny that, then you're a non-reductive physicalist, or as she would say, a weak emergentist. So the idea is supposed to be that all 6 of these are perfectly coherent positions that you might adopt. And you don't necessarily have to adopt one of them all the time, right? This can be case dependent. Like in some cases you might think, oh, that feature we'll talk about doesn't exist. In other cases you might think that feature people talk about is reduced. So you can be case by case about this, right? You're not committed to just, one view for all time. But these are supposed to be 6 coherent positions. But only the latter 2 she thinks have any claim to emergentism as a name. It seems clear that if you deny one of the first 4, according to her, you're just not an emergentist. And of course, the idea of a hexalemma is that you've got to deny one of them, right? You can't have all 6. You can't have your cake and eat it too. So why is that? Why does she think that? Well, so here, right, we've got a physical situation, PNP Star, and the idea here is supposed to be that if P star is a physical occurrence, we just pick P. P is whatever physical cause that had. And we're guaranteed that that exists by the completeness of physics, right? So the causal closure says that if you have a P star, there must have been a P. And then, we take this S, and S, it must be distinct from P by distinctness. It must exist. Some S exists by existence. It's not equal to P by distinctness. By causal efficacy, it has to, produce an effect. We'll assume at the special science level, produce some effect S star. But S star, it's also, is supposed to be dependent on something. So P star, right? So you got this kind of box just from the premises. And then she says, look, well, if we have the box, it sure looks like P is also cause of S star. Because after all, whatever kind of normal kind of causation you want, if I twiddle P, then, I twiddle P star, but S star supervenes on P star, so that means, I twiddle S star, or I could twiddle S star, by doing something with P. So it looks like P should count, also as the cause of S star, but now we have overdetermination, right? That's the hexalemma. You have to give up something. You don't give up something, you stop. All right, so then I want to kind of dive in a little bit on some changes that happened to this hexalemma over time. So first of all, as I tried to flag earlier, I say in 2015 this is just in terms of features. This is the feature S, the feature P. But this actually is part of the 2021 account too, is that you have supervenience, but again, you also have requirements. So there's actually kind of an if and only if relation here. So it's a bit stronger than you might expect. Then what happens in 2021 is that she wants to introduce the question of entities, not only of features. She wants to run the argument in terms of entities and features, and she wants to kind of expand material dependence a little bit. So in this case, so she says if we're just talking about features, it's supposed to be this minimal nomological supervenience, which is a both directional relation. But she says, look, even if we don't have minimal nomological supervenience of S on P, we can still have material dependence of S on P if S is a feature of some entity, I just say ES, whatever entity bears S, and P is a feature of some entity EP, whatever entity bears P, and ES depends on EP. And that's an unanalyzed notion. So this is entity dependence. She doesn't tell us what that means in the book. She just says, look, another way to have material dependence without minimal nomological supervenience is just if the features depend on entities and the entities are somehow dependent, whatever that means. And then, in a footnote, she says, and also, by the way, there's a trivial kind of entity dependence you can have, which is where ES and EP are the same entity. So if S is a feature of this entity and P is also a feature of this entity, then entities trivially depend on themselves, she says, so now S will materially depend on P. Notice how, again, this might seem more symmetrical, like of an account, right? Because here, what really makes P and S separate? All we're claiming is that they materially depend on each other because they're born by the same entity, but that doesn't really tell us anything about the direction of the dependence, right? So this and this are both kind of maybe oddly symmetrical accounts for what you might think. We can talk about that later if you want, but just to flag a little bit about how dependence evolves. This is going to be important for understanding how Lonergan's account fits in here. All right, and another one thing I want to flag that'll come up in the comments is her evolving understanding of causal closure. So in 2015, which by the way, this paper is supposed to be like her summa of her 20 years of work kind of thing. So it's not just a random statement. It's like we're told it's kind of a definitive statement. Every lower level physical cause has a purely lower level physical cause. Every effect has a purely lower level physical cause. And then in 21, she tightens that up a little bit and adds this word sufficient. And so the reason I flagged this is just because I like the 2015 account better, even though it's obviously earlier and presumably she had reasons to go to this. Why? Because this seems to exclude stochastic laws. So this is a nice pair with the previous talk, if you were here for that. Right? Because here, if there were any stochastic laws, right, just say that, GRW or some other collapse, version of quantum mechanics is true, which it doesn't seem like our account of emergence should depend on like what account of QM we give. I mean, that seems like too much coupling. Then we should be able to characterize physical causal closure in terms of GRW. If all the world is nothing over about GRW, then it seems like we should have physical causal closure. But here you actually wouldn't, because physical events wouldn't have sufficient causes. So so I don't like this, and I'm going to argue for moving back to that one on that basis. All right, that's Wilson. So now with Wilson in hand, we can move on and talk about Lonergan's account before I compare them. So unfortunately here there's some terminology, but you'll bear with me. So Lonergan introduced the word conjugates. So conjugates are correlatives defined implicitly by empirically established correlations, functions, laws, theories, and systems. So say that Newton's physics was true, mass here would count as this kind of implicit conjugate, because after all, we don't sort of directly experience mass. What we experience is forces. We see accelerations. How do we know what the mass is? Well, by plugging it into the things, right? We see the law of gravitation. Take the law of gravitation. We have F equals ma. So we can plug in and get these differential equations, and we see that these are verified. Like, oh, that in fact is how things accelerate in the world. And then mass is just whatever it is that makes all this kind of come true. We don't have to have a direct experience of it. So it's a little bit like a property, we might say, but it's a property that's like implicit in a scientific theory. Then he wants to introduce the idea of a thing. So a thing is grounded in insight that grasps not relation between data, but a unity, identity, or whole in data. This unity is grasped not by considering data from any abstractive viewpoint, like we did before, but by taking them in their concrete individuality and the totality of their aspects. Things possess properties subject to laws. So Fido, classic example of the thing. So Fido is not known implicitly by a set of laws, but rather by our concrete experience of this golden retriever. But of course, Fido is subject to the laws of the conjugates. Fido has a mass, Fido obeys F equals ma, you know, et cetera, right? But even though he's not mentioned in any of those equations. So it's something like a substance, but he doesn't want to get too stuck into the metaphysical baggage of what that might mean. And then last, we have the idea of a scheme. This is not going to be super important, but it's the diverging series of positive conditions for an event that might go around in a circle. So we have a series of events. Be so related that fulfillment conditions for each would be the occurrence of the others. So Fido eats, Fido mates, then there is, you know, Fidita, the baby, and then, you know, Fidita eats, Fidita mates, and then, you know, so there's yet another golden retriever, right? So we have, you know, there's a series of events. Dog eats, dog mates, you know, new dog is born. And they seem to kind of go around in a circle where when the first set are fulfilled, it creates the conditions for that set to be fulfilled again. All right. Why do I introduce all of this terminology? Well, let's look at how the theory ends up. So consider a genus of things, the TIs with the explanatory conjugates CIs, and a second genus of things TJs with the explanatory conjugates CIJs, such that all conjugates of the type CI are defined by their relations to one another, and similarly all the conjugates of CJ are defined by their relations to one another. Then, since CI and TJ differ, there'll be two differences in the terms and relations. Basic terms and relations differ. All logically derived terms and relations differ, so that by logical operations alone, there's no transition from one system to the other. I will give you an example, I promise, but I just want to kind of roll through the abstract theory first. Okay, so we have some things here, like say electrons. They have some properties like mass or charge, right? Here we have some things like molecules. Maybe they have properties like valence or, you know, place in the periodic table or something like that. But they also have mass and charge, right? Or could. So the things at this level bear actually both sets of conjugates. All right. So what does emergentism look like in that story? So the key notion is that we have the lower species of things with their conjugates and whatever schemes they undergo. They create aggregates of events, right? Some things happen in which, you know, F equals ma, you know, mass and acceleration, you know, accelerations are exchanged, you know, that kind of thing. And those stand in correspondence, he says, with a series of higher conjugates of another genus. So what's that look like? So I'm going to give the physics chemistry example. So, all right, sorry, this came out a little blurry at the scale, but all right. So we have the standard model of elementary particles, right? So these are going to be the TIs, and then they obey the laws of the standard model, right? Which, you know, include things like charge, etc., spin, right? So this is the standard model equation. So we have some TIs. They obey this law, which embeds in it the CIs, those conjugates like charge and spin that explain how they relate to each other. And once we know what the law is, what the conjugates are, and what the things are, then we can draw, as we know, a bunch of interaction diagrams, right? Which say, like, this is a thing, this is an event that could happen according to the laws that we've laid out. And, you know, those are going to be, each vertex is governed by the conservation laws, that kind of stuff, right? We have a whole bunch of different kinds of events which follow those laws and involve these things. And, you know, we measure conservation of the conjugates and whatever. And then, of course, these can, in big complicated cases kind of go around in circles. You can have one situation that then changes and then comes back, right? So we can have, you know, a photon can give rise to an electron and a positron, and then they can, you know, come back together and you know, in a whole set of arrangements, and then you end up with getting photons out at the end because all the, you know, matter and antimatter cancel or something like that. So you can get schemes. All right, and then what do we think that looks like with respect to the next level? Well, so the idea is that at the bottom level, what you have going on is a whole bunch of standard model interactions that you could put together with Feynman diagrams. They end up being like way more complicated than the Feynman diagrams we want to draw. And when those happen, when these events happen in some massively complicated pattern, what you see at the upper level is chemical reactions. So you see some, you know, yeah, you see some chemical reactions of these things. So, and of course the atoms and molecules then will again have the lower level conjugates. They'll have mass and charge and spin and all that stuff, but they'll also have higher level conjugates that don't make sense at this level. Like you can talk about the atomic number of manganese or the place of periodic table of manganese, and that's not a thing that strictly makes sense to ask about any of these things, right? None of the particles of the standard model, nor the events they undergo, have a place of the periodic table or an atomic number, right? Those are just going to be, in some sense, distinct properties. All right. Then Lonergan introduces the idea of a dilemma. So you might think then that, you know, what you have at the bottom level are some TIs, right? And then you have some TJs, and then you have some, you know, M's and, you know, P's and whatever, right? You just kind of go up and you've got things inside things. And he wants to say, is that true or not? Like, is it the case that there are things in things or not? And sorry, and why is this a dilemma for him? Why might just seem obvious? It just should be like this. So we might say the reason why this looks like the right picture is that after all, the CIs are preserved at this level, and these are preserved at this level, and so on, right? So if we have mass and charge at the bottom level, when we build up big things, they still have mass and charge. If we ask why that is, you might think, well, it's because the things that have mass and charge make them up, and, you know, so the properties refer to the parts. But this is where I have to lean carefully on his definition of a thing. So a thing is supposed to be a unity, identity, a unity, totality, and whole that we see in data. Remember, like Fido, we're just acquainted with Fido. Fido's a thing. But if that's the case, then in a way, when you have some kind of complicated thing in matter, these will never be totalities or wholes, right? Like the little bits are never going to be somehow a totality and whole of the data, they're just going to be a part. So it seems like they can't count as things, so you wouldn't have things in things. So the definition of a thing suggests that you can't have things in things, that you've just got the whole once you get emergence. On the other hand, we might think that since the laws of the lower science are verified in the higher science, then, you know, so should the things be. Okay. Yeah, so, but in the end, he ends up going for the option that there aren't no things in things. Why? Because it's one thing to prove that the conjugates lower order survive in the higher genus. It's another thing to say that the things defined by the conjugates survive in the higher genus. And he says, for conjugates, we're always abstracting. Again, we'll think about that in the Newtonian mass case, right? We just abstract. Or like spin for electrons, not a thing we observe, it's a thing we abstract from the behavior in the laws. But things aren't abstractions. Things are totalities, we take into account all of the aspects. So we have conjugates of the lower level in things, but we don't have things in things. So the point is, after emergence, so for Lonergan, it sort of looks like this. So we have a thing, it has some conjugates, therefore undergoes some series of events. Those events create the conditions for the existence of a higher conjugate, right? So when you have the right Feynman diagrams going on, then you can have chemistry. When you've got the higher conjugate, then we say, oh, there's a thing. If we've got chemistry going on, then we can identify a periodic table, which is labels of things. But rather than it being the case that the CIs are somehow born still by the TIs down here, there's no line down here, right? No, the CIs have to be born by the TJs. In other words, somehow the lower level particles be all born by the top level thing. Because there can't be a bottom level thing, because things are totalities by definition. All right, thanks. Okay, so to the, how does this fit? Why should we care in terms of Wilson's schema? Okay, so first of all, I want to say that epistemically, Lonergan's view should look like weak emergence. So when Lonergan says events at the lower level correspond with events at the higher level, that looks at least like Wilson's kind of medium supervenience, right? You don't have chemistry without, the relevant things going on, the relevant, sorry, not things in technical sense, but the relevant events, complexes going on at the lower level, so there's supervenience. Lonergan's going to say that the relations are coincidental in the sense that looking at the lower level itself, just staring at all the Feynman diagrams wouldn't really give you like a good sense that there's chemistry going on now, right? You just see like one pile of Feynman diagrams and another pile, like you probably wouldn't like invent chemistry by doing this. So it's coincidental in that sense that you don't kind of predict the higher thing. So this looks like a deducibility in principle situation. If you really saw it all, you could predict the higher patterns, but we're not good at it, it's deducible in principle. So this looks like weak emergence, right? Lonergan, you say, okay, this is just a weak emergence view. But from a powers perspective, it seems like it should be a strong emergence view, because there are new powers at the higher level, like the power to undergo chemical change or whatever, that just aren't part of the lower level on Lonergan's story, right? That's the CJs are genuinely new conjugates. Why do we think those conjugates exist? Because they feature in laws. So there's somehow kind of powers of the things at the higher level. So it looks here like it's strong emergence. All right. So how does the trick work? You might ask. Well, how do we pull it off? Well, remember this third option from Wilson that I showed you. Well, here we have it, right? So the CI, if this is the S, right, the CJ, on the CI is the P, they actually both depend on, they both are, conjugates of this thing, the TJ. So the stuff at the lower level, the mass and spin, we attribute those to the molecule, but we also attribute the place in the chemical pattern to the molecule. So they're both born by the TJ. So we actually have this situation where we have trivial material dependence in this story. All right, so what about physical causal closure, though? How do we avoid violating that if somehow these things are dependent on chemical things and not physical things? Well, the answer is that so each lower level physical technical effect has a purely lower level physical technical cause. So that we have, right? So the CIs are caused just by previous kind of schemes of CIs. That's it. But the question is it plausible that P causes S star? And there are various takes you can go, but for the simplest one, let's just assume that this actually is stochastic. That there's, GRW is true or something, right, and this relation is stochastic. Well, it might be the case that you can never have a better information about whether P star is coming than by using P, right? So this really is P is the best cause of P star, the best explanation, the best candidate cause for P star. But here, we might actually have something non-stochastic, right? So we might think that the stoichiometry at the chemical level isn't stochastic. That if you put this in, you're always going to get this out, even though what's going on at the lower level might be stochastic in terms of the Feynman diagrams. So now, S looks like the best cause of S star because it's actually a deterministic cause. It looks like a better candidate for the cause of S star than P does, because P only causes S star probabilistically, S causes S star deterministically. So they're not this is not actually an equally good candidate there. So we don't have competing causes, even though we never have downward causation. We never have anything where this is actually causing something at the lower level. So I would suggest that this ends up being an importantly different account than Wilson's. So it's weaker than her strong emergence because there's no failure of deducibility in principle. You have all the information at the lower level. You can compute the higher level. And there's no violation of physical causal closure. So it's weaker than strong emergence. There's no downward causation here. But in another way, it's actually not just stronger than weak emergence, this is not a typo, but stronger than strong emergence. Because, why? Well, the lower level things, not the conjugates, but the things go away. Right? So, when you have a molecule, there are no quarks in there. There are no electrons in there. They don't exist. So in a way, that's like a radically strong emergence account, right? So in one way, it's much weaker than strong emergence, pure weak emergence, but in other ways, it's even stronger than strong emergence. So whether this is attractive, I mean, obviously this is, you might think this is a big intuitive, cost to bear, fair enough, but obviously people have been fighting over the hexalemma for a long time. If this is a way of getting out of the hexalemma, to have your whole hexalemma cake, because you deny this adjunct assumption, then, that's a reason to consider it. Beyond that, I just want to say that Wilson's characterization of dependence ends up being a little inadequate, right? Because what it shows is that when you have a kind of, you should have an asymmetric relation here, but she gives you what looks like a symmetric relation, so that allows you to things come apart in different ways. And she also seems to think that you can just swap in features or entities willy-nilly as you like in her schema, but Lonergan shows why that doesn't work, because if you are going to talk in terms of the features and entities relationship can kind of come apart on this kind of super strong emergence account where the lower level entities go away, but the lower level features don't. So basically Wilson needs to take more, stock of this stuff. So, over to Tyler.
Thanks, Ryan. We now have comments from Tyler Millhouse from University of Arizona.
All right. Thank you, Ryan. That was a great talk, and I really enjoyed reading the paper. It made me think about a lot of these things again in a new way. And some of the marks are really great. A really great paper. So I have a few issues here. I'm going to see how I do on time. I'm just going to kind of go through these. And I might have a surprise one if that's okay at the end. But I just thought of if I do have the time to get to it. All right. So I think this, we had talked a little bit earlier about this issue of distinctiveness and identity. And I just wanted to throw out there, I don't necessarily expect Ryan to respond to this, but it's just sort of a hobby horse of mine that how we figure out whether two things are distinct probably shouldn't be done in terms of whether there's identity relationships that can be drawn between them. I do like this kind of more asymmetric point that you talk about, but I worry that comes in very different flavors, right? So, I mean, it's one thing, right, to be able to identify, say, explicitly certain terms in one sort of way of viewing a system, with certain terms in another way of viewing it. But it's very different just to say that maybe we can map in a sort of bijective way points in the state space over here to points in the state space over here. That could happen in a lot of ways. That function could be more or less complicated. Of course, we can just say, well, actually, this variable here is this variable here, kind of a relabeling thing. And so I guess I just worry that distinctiveness kind of comes in degrees, but maybe either the way the Lonergan was setting up or the way Wilson was setting it up made it a little bit too binary. So that's just an aside. But going more to the actual paper here, I want to talk first about the physical causal closure stuff, and I'm just going to read a quote from the paper if that's okay, so you don't mess anything up. All right. So actually, could I bring up the slide that has the P and S?
Just the back.
Yeah. Just as a visual aid. That one, okay. Okay, so this is what the quote says. P does not plausibly cause S star. P's relationship to P star is only probabilistic, and hence P's relationship to S star is only coincidental, while S offers a strong, non-stochastic explanation of S star. S offers a better explanation of S star than P does, and so is more fittingly called the cause of S star. Nor does S threaten to become an overdetermining cause of P star on Lonergan's account. P star may trivially, materially depend on S star and even be partially grounded by it if P star does not supervene on S star. All right. So I was wondering when I read this whether this is something that you need to sort of adopt a Lonerganian account to accept, right? So if someone happens to be, I guess, an epiphenomenalist, the person who rejects the final lemma of the hexalemma, But I wonder why they couldn't just read this and say, oh yeah, that's actually right. I wonder if I can just break this hexalemma right now and just accept all 6 of these things. Because this reasoning seems really just about causation itself, and I don't quite see how this turns on any of the most distinctive things about Lonergan's story, right, where you have the little things disappearing and these conjugates being attributed to these new and emergent higher level things. So that's one issue. The other issue is I'm not totally convinced by the reasoning in this passage in any case, right? So let's see, we'll look on that one book again. It says P's relationship to S star is only coincidental, while S offers a strong non-stochastic explanation of S star. And I think the idea here is that you might have some lower level dynamics that are stochastic, but nevertheless identify maybe some special science laws that are deterministic. I wonder if that's really the sort of thing that should make us think that S is a better explanation for S star when we're talking about tokens of those things, right? Because I mean, I think that causal relationships are really there, says they're manifest in the world in the tokens. The token of S causing a token of S star, and a token of P that's causing a token of P star. But if you put it like that, then there may be there's not going to be any deterministic causation of higher level. A given S star will not deterministically cause, a given S star will not deterministically cause any given S star. And it seems like, in fact, we could probably make a better prediction about the particular token of S star that we're going to see by knowing P than by knowing S, right? And this, when we were talking before, this kind of got to the issue of like this idea of Wilson's point about causal closure. But it seems like one of the key things about this fundamental level, if that's what P is supposed to be here, is it kind of has all the information. Even if it's stochastic, it has all the information. You kind of can't do any better as far as predicting future states of the world than by knowing what that is and using it appropriately. So it seems like in this case, I just don't know if that reasoning goes through, right? Because it looks like P will probably end up, the token of P will probably end up being a better predictor of the token of S star than any given token of S would be. All right. Let's see. I guess I was worried about a kind of different kind of overdetermination here, which is like the overdetermination of powers, right? It seems like by baking these things both into one thing, like the lower level power and the higher level power, that's the way you want to frame it. I just worry that given the kind of dependence that does exist between the higher level stuff and the lower level stuff, that it might just be an overdetermination of powers. I just wanted a little extra clarity on why that would be a more desirable thing to have than just an overdetermination of things doing things, right? All right, how many do I have time?
You've got 3 minutes.
Oh, perfect. The last one is just about the totality thing. I actually meant to include this in my original comments, but I guess I'm just worried a little bit about these holes getting out of control. I guess, I mean, we're part of society, maybe we're part of the universe, there's maybe nothing more total than that, right? And I just wonder if it ends up just being one thing. Maybe that's a feature on some metaphysical views, but I would take it to be a cost. So I just wondered how that works when it does seem like humans are part of certain larger wholes, or just any higher level things, often part of a larger whole. So, all right, I'll leave it there.
I think another response from Ryan.
Yeah, thanks so much, Tyler, for the comments. Given the short time, I'm just going to focus on 2 things and then try to grab the extra one you put at the end. So, all right. So I'll kind of skip anything exegetical and just go to the interesting metaphysical point. So the first is whether Lonergan's kind of Thomistic story about emergence, which denies the synchronic existence of the upper and lower level entities, is a necessary ingredient avoiding the hexalemma. Given, can't we just take this story by causation, as Tyler said? Well, the problem is that in the absence of trivial material dependence by a common entity, Wilson requires a minimal nomological supervenience for material dependence, which he in turn defines as the co-occurrence of S star and P star in similar worlds. But if S star and P star always co-occur, and S is a good explanation of S star, then S looks like a good explanation of P star. In Lonergan's case, you don't really need co-occurrence here because you just have, of all the features, you can have multiple realization or whatever, because you get material dependence by the common entity. So that's, I think, the difference there. The second question is about the efficacy of special science entities. So, given the tokens of type S deterministically cause tokens of type S star, do candidate tokens of type S deterministically cause particular tokens of type S star? Tyler wonders. If not, then P looks like a better cause of S star than S. Thankfully, it's indeed the particular tokens which are caused. So the parents of Finito are not just golden retrievers, but by Kripke's essentiality of origins, the particular golden retrievers, Fido and Theta. And the same thing holds in chemistry. Stoichiometric laws conserve elements not just at an abstract level, but because chemical reactions kind of conserve atoms, and the identity of those atoms is the particularity of the molecule. So it's not as if we're just, it's not as if it's just type causation. The tokens really are, in the picture. So, and then the last, sorry.
The totality thing.
Oh, the totality thing, right? How many do we get? Yeah, so I think actually a really nice thing about Lonergan's account is this just becomes an empirical question. So, for Lonergan, right, in order to have a higher level of like TJs or whatever, we need a level of CJs, a level of implicit conjugates. So the question would become how high are the level at which you get this really fully implicit conjugate scheme. And so I think we have something pretty close to this, at least maybe not quite close to this in at the bottom level because of the standard model. We have something like this for chemistry because we have the periodic table. I don't think we're anything close to this for psychology, and certainly not for like sociology or whatever. So it's only when you get a completely implicit system that you get properly speaking, a level for Lonergan. So I think it just becomes an empirical question. I think that's actually kind of nice. I think it's just an empirical question, how far composition goes.
One of the things is overdetermination of powers.
Yeah, I mean, I think I'm just going to leave it there because I think we're probably, yeah. So, cool.
So we actually have 18 minutes for Q&A. If you have questions, please raise your hand and leave it up. And I will start with David.
Hi, just a question, trying to understand what's going on. So, can
Yeah.
you look at the last slide, because I know next to nothing about Lonergan.
Sorry, the last.
The last slide we mentioned the thing about disappearance, was it?
Yeah, so here. Is that what you mean? Or?
You said a lower level disappearance.
Yeah, so here there's no, after this point when the CJs come into existence, there are no more TIs, yeah.
So what's an example of that? Like, how can you catch
So
that in some
the
sort
claim
of-
would be once you have the formation of molecules, there actually, strictly speaking, are no more electrons.
Yeah, and, okay, so is he appealing to Aquinas for that or something like that?
Well, it's not really an appeal. I mean, it sort of follows from the definition. I mean, his idea is that things are totalities, and conjugates are abstractions. And if you have a bigger thing, then the smaller thing isn't a totality anymore. So, sort of by definition, it's not a thing.
So is he denying the existence of composite substances?
In some sense, yeah. I mean, it depends quite what you mean by it. So, sort of following Aristotle, it's not that you can't have like regions or something like that, right? But you won't, strictly speaking, have you won't have substances and substances. You won't have like actual all the property bearing will be done at the top level. That doesn't mean that like by some definitions of composition, I mean, whether he's a nihilist about composition or not depends about exactly how you want to cash that out. But what certainly won't be the case is that none of the parts of substances, if you want to say that they have parts, will be parts that pre-exist the existence of the thing. So you won't have any parts carried through into the thing. That's right. So it's absolutely a radical view. I think there's reasons in favor of it I give in other papers, but the reason I'm giving in favor of this paper is basically just if you think that the 6 things in the hexalemma are painful, which a lot of people do, that's why it's a hexalemma, that's why people have been fighting about it for a long time, well, this at least gives you a 7th thing that you can deny. Whether you want to deny that, and, if you're really happy with denying one of the original 6, then, maybe you don't see much motivation to deny the 7th thing If, on the other hand, you're a little conflicted about the original 6, well, you've got a 7th tool in the toolbox.
Sam.
This is related. Doesn't this just mean that number 1 in the hexagon is false? Because the TI is not co-located with the CJ temporarily? It was, but it isn't now.
But so the hexalemma is in terms of features, not in terms of entities. So the CIs and the CJs are cotemporally located, right? So the question of the feature like group in the periodic table and the feature, charge and mass are temporally and spatially co-located.
So you have properties of, so when you've got a molecule, you've got properties of the like atoms but no atoms.
Mm-hmm. The properties get transferred, yeah, that's,
The properties are just floating.
they're not floating, the properties are properties of the molecule. It's just.
Oh, so the molecule comes to have the properties of the atom.
Well, as like in a spatially, distributed way or whatever, yeah.
Okay.
Yeah, no, I mean, it's definitely, again, I'm not saying this is an easy bullet to bite.
Yeah.
I'm just saying that historically, none of the other 6 really have been either. I mean, individual people, of course, might have no trouble, biting one of the original 6. But like, as a philosophical community, we haven't done very well at deciding which one of those 6 it is. So, yeah.
Just a very trivial follow-on question. So if he says the atoms making up the molecules kind of disappear into the molecules, then how does he deal with the fact that I can just take that molecule, break it apart, and I get the atoms back, and I can do that back and forth as many times as I want, which really looks like one is made up out of the other. So and I guess that a special power or whatever in the totality that it can go back into what I would consider parts, and it's always the same parts, it's never anything else. That seems very remarkable.
Yeah, I don't know if it's quite as remarkable as people sometimes think. So by example, it seems like there are some good reasons to think that that quarks are not in an unproblematic way in, say, protons. Just in the sense, like not like sort of just pre-existing things in there, as if like there are just these 3 quarks and they are there. I mean, there's a kind of like, a giant quark soup, by which we mean a kind of superposition of lots of different quark states in there. It's not like the 3 valence quarks are somehow like these 3 things are what is in there. Quarks are only seen in a bound state. We don't really see, it's not like we just take them in and out in a kind of like toy block kind of way, right? And yet, when you smash up protons, well, you always get, the 3 valence quarks. So I don't know that the mere fact that we get something out in a predictive way should itself imply that those things were already in there. It might depend on what the laws are that govern that reaction. So I think we see that, and certainly it's the case that like, we don't think that there's like a positron and an electron inside a photon, even though like the one thing a photon can do without interacting with anything else in the world is, split into matter and antimatter, right? But it's not as if they were like already stuffed in there, like bound real close together, and that's what a photon is. You don't want to say that. So I don't think that the predictability of the physical law itself gives us evidence in this regard, but.
Yeah, so I'm sure I'm missing something, but why is it that, I mean, I'm still puzzled by the TJ having the CIs, but in the spatially distributed way. I mean, one thing is that it seems like it's not just having the CIs, that's like another property, but why doesn't having all the CIs in the spatially distributed way compete with CJ for whatever TJ is involved in causing? So I mean, like mental causation debate, like you said, it fit the structure of you have a single thing, supposedly with physical properties of having a brain in a certain state and the mental property of having a certain mental property, and that was, you can set up the mental causation debate, and they're meant to compete, right? So why doesn't these 2 things of TJ compete, and why don't the CI, having the CIs in the spatially distributed way, potentially exclude the CJ, or why don't they, because the properties are involved in the causation, right? So why, how do we
Yeah, so I
avoid
mean, the story, so again, what levels exist is going to be an empirical question for Lonergan, right? So it's not, no, I'm just warning us there.
Yeah.
So Lonergan's not pre-committed to like there being a separate level of the mental, right? He's not, like, emergence becomes a really empirical question, not like something we're pre-boxed.
That was just illustrative.
No, I understand. I just wanted to flag that. So we're not pre-committed to like where levels exist or where they don't. But then the question would be, so it seems like at least it might well be the case that at the level of neurological transition, so the question of like when one, I'm not a neurologist, so forgive me, but when one neuron fires, like what other neurons fire, or whatever, might be in some sense probabilistic, right? Like we stimulate this neuron and fire it, and like most of the time it's a little bit like in this pattern that you got over here, but it's not like always exactly the same other ones that fire, right? There's a little bit of stochastic stuff in there. Yeah. So if then, we course grain and go up here, right, and we say, okay, this belief looks like this antecedent, neuron firing, and then like, if S star here is like, like here, like S is like you're hungry, and S star is like, you go off to lunch or something like that, right? The idea, so, P might ground you're hungry, it's a certain, set of neurons that have certain properties, and P star over here might be a certain pattern of motor neuron firings, right, that are taking you to lunch. But which motor neurons fire in response to this might vary a little bit, right? So I might start walking with my left foot first, I might start with my right foot first, I might do different things. So the the details of what happens here are going to be stochastic, or could be, right? Again, it's an empirical question whether they are, but if they are, then it looks like S, the state, is not really a good explanation of which motor neurons are firing, because the mere fact that I'm hungry didn't explain that very well, not nearly as well as this does. And conversely, the fact that I'm hungry is a much better explanation of that I'm going to lunch than this is, because this to this, you have to go via here, which is via a stochastic link, which makes it seem like a less good candidate cause than something that's going through a deterministic link. Maybe with the feeders, but I mean, that's leaving that aside, but it's in the ordinary case. This might be deterministic. Every time I'm hungry, I go to lunch. So it looks like a better candidate cause. So that'd be the kind of story.
I'll follow up after, unless we've got time.
You can follow up.
But it is because I didn't follow the whole thing about tokens issue, but you think that token S star could have occurred, but that token, like getting the sandwich, could have occurred with me moving in a different way.
Yeah, sure. I mean, you did in fact go to lunch. I mean, yeah, well, it seems
yeah,
like
sure, but that's. I mean, it's not, especially if it's grounded by like the token P star. It's not obvious that like it has an identity separable from the low other things that realize it and make it real, right?
Well, Lonergan's case that it has such an identity would be precisely when, and again, I don't know if this is true at the psychological level, that's why I focus on the chemical level, where I have a little more knowledge and where I think our science is a little further along. But the question would be, are these defined by a fully implicit series of terms and relations? So in the chemical level, like the way that Mendeleev and Cannizzaro kind of cooked up the chemical array was by doing reactivity experiments, right? Seeing like what reacts to what, and then seeing what the stoichiometry was. And it's actually from the stoichiometry that we got the atomic weights, right? Not the other way around. Which might sound funny, but that's actually how it goes. So if that's the case, then the claim would just be, look, we then have a way by individuating the things up here, a fully implicit theory that's 100% confirmed, that doesn't actually make reference to lower level theory. So we should take it as being distinct and real, etc. Then the only question becomes, can I, reduce it? And here the answer would be, no, you can't, because you have multiple realizability, etc. So,
Alex.
Thanks. I was wondering, there seem to be some properties of higher level things that reference entities at the lower level. So, I mean, a very simple example is a hydrogen atom has one proton, right? Something like that. Are those sorts of properties just not permissible on this picture? And I have a separate kind of case also.
yeah, so I think this is part of why Lonergan spends so much time cooking up terminology, which can be annoying for, you know, if we just like want to dive in for something and we don't want to, you know, read this huge, I mean, this is like a 700-page book, so like, it's annoying, right? But I think this explains perhaps why he bothers to do it, because, so, property, whether it's a property of having a hydrogen atom, well, it, you know, it's something that we would always say they always go together. If there's one hydrogen atom here, there's one proton here, something like that. You know, I don't know. He doesn't want to speak that way, partly because the point is that there wouldn't be, strictly speaking, having one proton isn't a conjugate, right? So it's not, because the conjugates are the correlatives that are defined by the laws, theories, or systems. So in this case, you know, the bits like, you know, mass or charge or spin, right? They're not the bearers of those things. So strictly speaking, having one proton just can't be a conjugate. So it just doesn't really fit into this system.
Can I try
Yeah.
a different one?
Yeah, of
So, a diamond scratches a piece of glass, in part because the strength of the covalent bonds of the diamond molecules break apart the covalent bonds of the glass. This seems to be, so wonder what you think about that sort of case.
Yeah, I mean, I think I would want to say something like, so I think that's fine, because I don't think, like I would say that the diamond and the glass both exist at a chemical level, not at a higher level. And bonding, I would say, is a chemical phenomenon, strictly speaking.
So the diamond doesn't scratch the glass, that's something that's not going to be interpretable in this picture. It's just the happenings at the chemical level.
Wait, why doesn't I mean, scratch the glass again, like, so the question would be, can we define that in terms of, you know, a law? So it seems like if you're speaking in kind of if scratching is just a kind of common sense observation, it doesn't strictly fit into the schema, right? So you'd want to.
I mean, we've got theories of, you know, scratch resistance and sorts of things.
Well, Lonergan's giving you a really, really high bar for a theory, though, right? So be careful. So this is not just like anything that like appears in a good scientific paper that's reproducible, right? It has to be fully implicit. And I would say that scratch or something like that probably doesn't have a fully implicit definition. So really, like, there are only going to be a couple theories in all of science on Lonergan's view, right? You might have like the, you know, GR, the standard model, the periodic table, which I defend as a theory in other work, along with like Michael Weisberg and others. But you're not going to have very many, right? Like, you're going to have very few theories. And this is only going to, strictly speaking, apply to like these kind of full theories.
So it may not help in the
Alex, I'm going to shut you down.
Yes.
Yeah, well, let me just say one thing, because I think it's, so I would just say that models also do a lot of work in science. It's not only theories that do work in science, models also do work in science. And we're going to be much more permissive about models, right? So models can blend theoretical elements, common sense elements, you know, don't have to be kind of strictly applicable to unrestricted domain, right? Like, so Lonergan would say that models are super useful in science, we use them all the time, and they're great, but they're not guides to ontology the way theories are. That would be the distinction.
So we have 2 minutes left and 2 people in the queue. So back, I don't know your name, sorry.
Yeah, that's okay. Can you go back to the previous slide there, the score?
This one?
Yeah,
Okay, sorry.
So, and this probably just amounts to a clarificatory question, but, so I do feel bio, debates like this go on, right, between molecular biology and phenotypes and genotypes and all that. So I'm trying to map this framework on there. I'm trying to make sense of it, so I can say something like, okay, P is down at the molecular level, it's a string of nucleotides. S is help me out here. So S is a genotype that leads to a phenotype. P is the particular string there, and so in this way of working it out, what he's going to say is it's just an empirical question as to whether or not I'm ever going to get a non-reductive account of a gene, and it's just as we do further science, we'll make that determination. But okay,
That seems good.
Then if that's the case, I'll talk to you after the end of the talk. I think there might be a couple possibly problematic counterexamples that I can think of in the biological sciences.
No, I love that.
Okay.
Okay, Tyler, for a
That'd be
second.
great.
Okay, very quick. I think Alex actually kind of was really irrigating what I was saying about the concern there. But I guess it just does seem to me, right, that, you know, if I'm hungry and then I walk to go get food, the very particular way in which I walk to go food, that very token event of walking to go get food would be different if the physical state were different. It wouldn't be the same token. And if there's lower level stochasticity, then I don't see how there couldn't be stochasticity between tokens at the higher level. Another adjacent point is just that I don't know.
I don't know that you have time.
Okay, no adjacent points.
Okay, so I'll just say that this does a really important, a lot of the work here. So the idea is that what identifies the things is precisely their role in the top level full theory nexus, right? So this is why, I mean, I know you're a philosopher mind, so I wanted to like engage, you know, at that level, but like, that's why I haven't talked about that, right? But so if we took these, if you said, well, if the things at the lower level were differently distributed, then you would have a different token molecule, say, right? I would say that's not obviously true. So for instance, that quark soup is constantly changing in state. The electrons are, you know, moving up and down to different energy levels, right, as, you know, stuff comes in and out. It might be ionized and then, you know, steal an electron from something else and go back to a neutral state, right? So you're getting all kinds of differences down here at this level that are perfectly compatible with it being the same molecule. So I just don't think we want to define the same molecule as an exact state of what's going down here. That just seems wrong.
Please join me in thanking Ryan and Carter.